M1, better known as the Crab Nebula, was the nebula Charles Messier originally mistook for Halley's Comet, which inspired him to create his famous catalog of objects. With an apparent magnitude of 8.4 and located 6,500 light-years from Earth in the constellation Taurus, the Crab Nebula can be spotted with a small telescope and is best observed in January. A rapidly spinning neutron star, the ultra-dense core of an exploded star, is embedded in the center of the Crab Nebula. The neutron star, like a lighthouse, ejects twin beams of radiation that make it appear to pulse 30 times per second as it rotates. In 1054, Chinese astronomers took notice of a guest star that was, for nearly a month, visible in the daytime sky. The guest star they observed was actually a supernova explosion, which gave rise to the Crab Nebula, a 6 light-year wide remnant of the violent event. The first globular cluster to be added to the Messier catalog, M2, is located roughly 37,000 light-years from Earth in the constellation Aquarius. A globular cluster is a spherical group of stars that are bound together by their mutual gravitational attraction. M2 has a diameter of over 150 light-years and is one of the largest clusters of its kind. M2 contains over 150,000 stars. Most of the cluster's mass is concentrated at its center, with shimmering streams of stars extending outwards into space. It has an apparent magnitude of 6.3 and can be seen with the naked eye in ideal viewing conditions. The best time to observe M2 is during the month of October. Large telescopes will resolve the cluster's individual stars. The globular cluster M3 was the first object in the Messier catalog to be discovered by Charles Messier himself. Messier spotted the cluster in 1764, mistaking it for a nebula without any stars. This misunderstanding of M3's nature was corrected in 1784 when William Herschel was able to resolve the cluster's individual stars. Today it is known to contain over 500,000 stars. M3 is notable for containing more variable stars than any other known cluster. The brightness of a variable star fluctuates with time. For some variable stars, their period relates to their intrinsic luminosity, so astronomers can use those stars' brightness fluctuations to estimate their distances. This makes them extremely useful for measuring distances to deep sky objects. M3 contains at least 274 variable stars. The cluster is located 34,000 light-years from Earth near the constellation Bootes. It has an apparent magnitude of 6.2 and can be spotted using a pair of binoculars. The best time to observe M3 is during May. The globular cluster M4, located in the constellation Scorpius, is a huge spherical collection of stars known as a globular cluster. Just 5,500 light-years away, it is the closest globular cluster to Earth. Because of its apparent magnitude of 5.9 and proximity to Antares, one of the brightest stars in the night sky, M4 is relatively easy to find with a small telescope. M4 was discovered in 1746 and is home to more than 100,000 stars. The cluster is predicted to contain up to 40,000 white dwarfs, the cores of ancient dead stars whose outer layers have drifted away into space. As white dwarfs age, they grow cooler, fainter, and more difficult to detect. Therefore, a globular cluster's age can be inferred from the age of the faintest white dwarfs. Because the stars in these clusters are some of the oldest in the universe, up to 13 billion years old, astronomers are able to use them to estimate the age of the universe. M5 was discovered in 1702 and is one of the oldest globular clusters in the Milky Way galaxy. It is located 25,000 light-years away in the constellation Serpens. M5 appears as a patch of light with a pair of binoculars and is best viewed during July. M5 contains over 100,000 stars. A majority of M5 stars formed more than 12 billion years ago, but there are some unexpected newcomers on the scene, adding some vitality to this aging population. Stars in globular clusters are believed to form in the same stellar nursery and grow old together. The most massive stars age quickly, exhausting their fuel supplies in less than a million years, and end their lives in spectacular supernova explosions. This process should have left the ancient cluster M5 with only old, low-mass stars. Yet astronomers have spotted many young, blue stars amongst the ancient stars in this cluster. These laggard youngsters, called blue stragglers, were created either by collisions between stars or other stellar interactions. Such events are easy to imagine in densely populated globular clusters.
The butterfly cluster M6 is an open star cluster located approximately 1,600 light-years away from Earth in the constellation Scorpius. Spanning about 12 light-years across, this cluster is home to a diverse array of stars, predominantly young, hot, and blue. These stars dazzle with their brilliance, forming a breathtaking arrangement resembling a delicate butterfly in flight. These celestial beauties are estimated to be around 100 million years old, relatively young compared to other cosmic entities. The best time of the year to observe the butterfly cluster is in the summer months, when Scorpius appears high in the sky for observers in the southern latitudes and is visible above the horizon to observers in the northern hemisphere. Visible right next to the stinger of the scorpion in the constellation Scorpius, Messier 7 is an easy naked eye target for stargazers in southern latitudes. The 2nd century astronomer Claudius Ptolemy first recorded this open star cluster in 130 AD, earning it the nickname Ptolemy's Cluster. Open star clusters contain stars formed from the same initial cloud of gas and dust and are typically irregular in shape. Over time, as open star clusters revolve around a galaxy, gravitational disruptions from other cosmic objects can disperse the stars. Ptolemy's Cluster is one of more than 1,000 open clusters in the Milky Way galaxy, and contain about 80 stars. Residing about 980 light-years from Earth, M7 likely formed around 220 million years ago. Astronomer Charles Messier added the cluster to his catalog in May 1764. M7 is the southernmost Messier object, making it challenging to see for those in the northern latitudes. It is located close to Messier 6, the butterfly cluster. Both M7 and M6 are best viewed from the northern hemisphere around 10 p.m. in July, when the Scorpio constellation is highest in the sky.
Commonly known as the Lagoon Nebula, M8 was discovered in 1654. This star-forming cloud of interstellar gas is located in the constellation Sagittarius, and its apparent magnitude of 6 makes it faintly visible to the naked eye in dark skies. The best time to observe M8 is during August. Located 5,200 light-years from Earth, M8 is home to its own star cluster, NGC 6530. The massive stars embedded within the nebula give off enormous amounts of ultraviolet radiation, ionizing the gas and causing it to shine. These two Hubble images provide two diverse views of the heart of the Lagoon Nebula. A visible light image on the top shows the billowing clouds of gas and curtains of dust from which new stars are forming, and a near-infrared view on bottom penetrates these clouds to uncover the stars hidden within and behind the nebula. Located only 25,000 light-years away in the constellation Ophiuchus, M9 is one of the closest globular clusters to the center of our Milky Way galaxy. The stars in the globular cluster are gravitationally bound to each other, with most of the stars concentrating at the cluster's center. This large central mass pulls outer stars inward and causes globular clusters to have spherical shape. M9's proximity to the much greater mass at the center of the Milky Way has warped the cluster's shape, so it appears less spherical than other objects of its kind. M9 was discovered by Charles Messier in 1764. It has an apparent magnitude of 8.4 and can be observed using a small telescope. The best time of year to spot the cluster is during the month of July. M9's neighborhood is interesting too, as it is marked by two vast and dark nebulae. These pitch-black clouds of interstellar dust are known as Barnard 259 and Barnard 64, and are clearly visible in wide-field images of the cluster. Discovered by Charles Messier in 1764, M10 is a globular cluster located in the constellation Ophiuchus. Messier 10 is a ball of stars that lies around 15,000 light-years from Earth. Approximately 80 light-years across, it appears about 2/3 the size of the moon in the night sky. However, its outer regions are extremely diffuse, and even the comparative bright core is too dim to see with the naked eye. This cluster can be spotted using a pair of binoculars or a small telescope, and is easily observed during July. The cluster is classified as moderately metal-poor, and there is evidence indicating it is enriched by elements produced in Type II supernovae. The stars in M10 have only 3.5% of the heavy elements found in the Sun, pointing to an age of 11.4 billion years. This makes M10 one of the youngest globular clusters known.
This star-studded image shows us a portion of Messier 11, an open star cluster in the southern constellation of Scutum. Messier 11 is also known as the Wild Duck Cluster, as its brightest stars form a V-shape that somewhat resembles a flock of ducks in flight. M11 is one of the richest and most compact open star clusters currently known. Astronomers estimate that it formed roughly 220 million years ago. Open clusters tend to contain fewer and younger stars than their more compact globular cluster cousins, and Messier 11 is no exception. At its center lie many blue stars, the hottest and youngest of the cluster's few thousand stellar residents. The lifespan of open clusters are also relatively short compared to those of globular ones. Stars in open clusters are spread further apart and are thus not as strongly bound to each other by gravity, causing them to be more easily and quickly drawn away by stronger gravitational forces. As a result, M11 will likely disperse in a few million years as its members are ejected one by one, pulled away by other celestial objects in its vicinity. M12, the gumball globular, was discovered by Charles Messier in 1764. This globular cluster is located 23,000 light-years from Earth in the constellation Ophiuchus. It has an apparent magnitude of 7.7 and can be observed with a small telescope most easily in July. Because globular clusters like M12 have such high concentration of stars, they often contain binary star systems, systems of two stars that are locked in orbit around each other. As the stars interact, material from one star can be transferred to its companion, producing X-rays in this process. These X-rays serve as a signature of interacting binary systems, and many have been detected in M12. M12 also has fewer low-mass stars than expected. Gravity has ripped many low-mass stars from M12 as the cluster passed through denser regions in the Milky Way during its orbit around the galaxy's center. M12 has lost up to 1 million stars this way.
Over 100,000 stars whirl within the globular cluster M13, one of the brightest star clusters visible from the northern hemisphere. Located 25,000 light-years from Earth with an apparent magnitude of 5.8, this glittering metropolis of stars in the constellation Hercules can be spotted with a pair of binoculars most easily in July. The English astronomer Edmund Halley discovered M13 in 1714. When Charles Messier added M13 to his catalog in 1764, he was convinced that the nebulous object did not contain any stars at all. Because they are so densely packed together, the cluster's individual stars were not resolved until 1779. Near the core of this cluster, the density of the stellar population is about 100 times greater than the density in the neighborhood of our Sun. These stars are so crowded that they can, at times, run into each other and even form a new star. The resulting blue stragglers appear to be younger than any other stars in their immediate vicinity and are the greatest scientific interest to astronomers. Discovered by Charles Messier in 1764, the globular cluster M14 is home to over 150,000 stars and has an apparent magnitude of 8.3. It is located 29,000 light-years from Earth in the constellation Ophiuchus and is best observed with a telescope during July. The total luminosity of M14 is on the order of 400,000 times that of the Sun, corresponding to an absolute magnitude of negative 9.12. The shape of the cluster is decidedly elongated. M14 is about 100 light-years across. A total of 70 variable stars are known in M14. In 1938, a nova appeared, although this was not discovered until those photographic plates were studied in 1964. It is estimated that the nova reached a maximum brightness of magnitude plus 9.2, over 5 times brighter than the brightest normal star in the cluster. M15, also known as the Great Pegasus Cluster, was discovered in 1746. This globular cluster is one of the densest ever discovered, with very hot blue stars and cooler orange stars becoming more concentrated towards its brighter core. M15 is located in the constellation Pegasus 33,600 light-years from Earth. Shining with an apparent magnitude of 6.2, the cluster can be spotted with a pair of binoculars. The best time to observe it is in October. M15 was the first globular cluster known to host a planetary nebula. This nebula, Peas 1, was discovered in 1928 and is one of only 4 planetary nebulae known to exist within a globular cluster. In this image, Peas 1 appears as the large, bright blue object to the left of the cluster's center. This cluster is host to a rare type of black hole at its center, an intermediate mass black hole. Supermassive black holes are found at the center of galaxies and can be billions of times more massive than the Sun. More diminutive stellar black holes, on the other hand, are on the order of 10 solar masses. The black hole at the center of M15, however, is 4,000 times the mass of the Sun. M16, better known as the Eagle Nebula, has provided Hubble with some of its most iconic images. These towering tendrils of cosmic dust and gas sit at the heart of M16. The aptly named Pillars of Creation, featured in this stunning Hubble image, are part of an active star-forming region within the nebula and hide newborn stars in their wispy columns. The blue colors in this image represent oxygen, red is sulfur, and green represents both nitrogen and hydrogen. The pillars are bathed in the scorching ultraviolet light from a cluster of young stars. The winds from these stars are slowly eroding the towers of gas and dust. Stretching roughly 4 to 5 light-years, the Pillars of Creation are a fascinating but relatively small feature of the entire Eagle Nebula, which spans 70 by 55 light-years. The nebula is located 7,000 light-years from Earth in the constellation Serpens. With an apparent magnitude of 6, the Eagle Nebula can be spotted through a small telescope and is best viewed during July. A large telescope and optimal viewing conditions are necessary to resolve the Pillars of Creation. M17, also known as the Omega Nebula or Swan Nebula, is one of the largest star-forming regions in the Milky Way galaxy. Hubble's stunning image of a central portion of the nebula has been colorized to highlight certain wavelengths of light. Green represents oxygen, while red reveals hydrogen and infrared light. The Omega Nebula was discovered in 1745. It is located 5,500 light-years from Earth in the constellation Sagittarius. M17, which appears near M16 and M18 in the sky, is best viewed on clear nights in August. M17 contains one of our galaxy's youngest star clusters, at only 1 million years old. However, many of the young stars in this cluster are impossible to see because of the gas and dust that surrounds them. The powerful radiation from the young stars evaporates and erodes the dense clouds of cold gas in which new stars form. One such pocket of gas is seen at the center of the brightest region of the nebula and is about 10 times larger than our solar system. M18 is a relatively dim open star cluster located in the constellation Sagittarius. The cluster lies at an approximate distance of 4,900 light-years from Earth. The cluster is estimated to be about 32 million years old, which makes it quite young. Most of the stars in M18 are quite small, but the cluster is home to several bright blue, yellow, and orange stars. M18 is located between 2 other prominent Messier objects, M17, the Omega Nebula, and M24, the Sagittarius star cloud. It can be difficult to find it because it is quite small, distant, and invisible to the naked eye. The best time to observe M18 is in the summer, when Sagittarius appears above the southern horizon in the evening. M19 was discovered by Charles Messier in 1764. The cluster is located 28,500 light-years from Earth in the constellation Ophiuchus and is most easily observed during July. It has an apparent magnitude of 7.7 and can be spotted through a pair of binoculars, though will only appear as a faint patch of light. Larger telescopes will resolve M19's individual stars. The stars in globular clusters orbit a common center of gravity, so these clusters are usually spherical. Some globular clusters, like M19, have a slightly elongated shape. This cluster is only 6,500 light-years away from the center of our Milky Way galaxy, so the gravity and tidal forces from the massive galactic center are causing M19 to stretch out. Discovered by Charles Messier in 1764, M20, also known as the Trifid Nebula, is a star-forming nebula located 9,000 light-years away from Earth in the constellation Sagittarius. M20 has an apparent brightness of 6.3 and can be spotted with a small telescope. It's best observed during August. A group of recently formed massive bright stars towards the center of the nebula is easily visible. These stars are releasing a flood of ultraviolet radiation that dramatically influences the structure and evolution of the surrounding nebula. Star formation is no longer occurring in the immediate vicinity of this group of bright stars because their intense radiation has blown away the gas and dust from which new stars are made. The image's stair-step appearance results from the design of the camera used to take the exposures, one of which provided a higher resolution but had a smaller field of view than the other three. Because the detector with the higher resolution did not cover as much area as the others, black regions were left when the images from all four detectors were combined into one picture. M21 is an open star cluster located in the constellation Sagittarius. It has an apparent magnitude of 6.5 and lies 4,250 light-years from Earth. M21 consists mainly of small, faint stars, but it is also home to a few blue giants. The cluster contains about 57 confirmed members, but it is pretty densely packed. It is classified as a Trumpler class I3R, which means it has a detached cluster with strong central concentration, consists of both bright and faint stars, and contains more than 100 stars. Stars of M21 are believed to be members of Sagittarius OB1 Association, a group of massive O and B type stars that share a common motion, age, and origin. The 8 of the 10 brightest stars in the cluster are spectroscopic binaries with periods shorter than 6 days. M21 is only 4.6 million years old, which makes it relatively young for an open star cluster. It is only 10% of the age of M45, the famous Pleiades cluster, and 1% the age of the Sun. M22 is a globular cluster located near the Milky Way bulge, the tightly packed group of stars near the galactic center in the constellation Sagittarius. It is one of the brightest globular clusters in the sky and was one of the first objects of its kind to be discovered and studied. With a visual magnitude of 5.5, M22 is the brightest globular cluster visible from mid-northern latitudes, though it never rises high in the sky for those in the northern hemisphere. M22 is 12 billion years old and contains at least 83,000 stars with a combined mass of 500,000 suns. This elliptical cluster lies 10,600 light-years from Earth. 2 black holes were discovered in M22 and confirmed by the Chandra X-ray telescope in 2012. The objects have between 10 and 20 solar masses. Their discovery suggests there may be between 5 and 100 black holes within the cluster, and that multiple black holes may exist in other clusters as well. The presence of black holes and their interaction with the stars of M22 could explain the cluster's unusually large central region. M23 is a bright, large, open star cluster located in the constellation Sagittarius. The cluster lies 2,150 light-years from Earth. Messier 23 has a radius of 15 to 20 light-years and contains 176 stars. M23 has an estimated age of at least 220 million years, which makes it one of the oldest known open clusters in our galaxy. The cluster lies northwest of the Teapot asterism formed by the brightest stars of Sagittarius. Small telescopes at low magnifications will reveal the cluster's brightest stars. M23 is located in an area of the sky rich in Messier objects and lies slightly to the north of the more famous M20, the Trifid Nebula, M8, the Lagoon Nebula, and the open star cluster M21. Messier 23 occupies an area roughly the size of the full moon. M23 is classified as a Trumpler I2R cluster, which means it has a strong central concentration and is detached from any surrounding star fields. Its stars have a moderate range in brightness, and the cluster is rich in stars, containing more than 100 members. M24, also known as the Sagittarius star cloud, is a large Milky Way star cloud in the constellation Sagittarius. It lies an approximate distance of 10,000 light-years from Earth. It is located in the vicinity of M17, M16, M20, M8, and M22. Messier 24 is sometimes called the small Sagittarius star cloud to distinguish it from the large Sagittarius star cloud, which lies further to the south and consists of stars in the galactic bulge that are not obscured by interstellar dust. M24 is about 600 light-years wide and lies in the Sagittarius arm of our galaxy, the next inner spiral arm farm to our own. It occupies an area 90 arc-minutes in apparent diameter and contains different types of objects, including stars and clusters that lie at a distance of 10,000 to 16,000 light-years from Earth, which gives the cloud a significant depth. In the night sky, the star cloud appears about 9 times larger than the full moon. The Sagittarius star cloud contains several dark nebulae, 2 additional clusters, 2 planetary nebulae, and several variable stars.
M25 is a bright, prominent open star cluster located in the constellation Sagittarius. The cluster lies 2,000 light-years from Earth and is about 19 light-years across. It is one of the Messier objects that are visible to the naked eye under good conditions, with clear, dark skies and no light pollution. M25 is pretty easy to locate with binoculars. It lies 6.5 degrees north of the star that marks the top of the Teapot asterism in Sagittarius. M25 is best seen in small telescopes of at least 8 inches in diameter, which will show about 60 stars of different colors. In total, Messier 25 contains 601 known members. The best time to observe M25 is in the summer, when Sagittarius can be found over the southern horizon in the evening. With an estimated age of 90 million years, M25 is not a particularly young star cluster compared to other clusters. M26 is an open star cluster located 5,000 light-years away and spans 22 light-years across in the constellation Scutum. This open star cluster is 89 million years old. M26 lies only a degree away from Delta Scuti, a particular giant star with a spectral classification F2 that serves as a prototype for a class of pulsating variable stars known as Delta Scuti variables. Messier 26 can also be found by first locating the bright star Altair in the constellation Aquila and extending the line formed by the stars that mark the celestial eagle's back in the direction of the Teapot in Sagittarius. The cluster is not visible to the naked eye, but will appear as a compression of stars in binoculars. Small telescopes will reveal a compact cluster of about 25 bright stars. The cluster contains a total of 90 members. The best time of year to observe it is from June to September. M26 is notable for a region of low star density near the cluster's center, likely a result of a cloud of interstellar dust blocking the light of the stars from our view. M27, also known as the Dumbbell Nebula, was the first planetary nebula ever discovered by Charles Messier in 1764. The term planetary nebula is a bit of a misnomer based on the nebula's round, planet-like shape. The nebula is a result of an old star that has shed its outer layer in a glowing display of color. Planetary nebula is what our sun will produce when it is near the end of its life and nuclear fusion stops in its core. These nebulae are formed when evolved giant stars eject their outer envelopes, exposing the hot core of the star, which then ionizes the surrounding cloud of expelled material with ultraviolet light. The clouds keep expanding until they dissipate into their surrounding space. M27 hosts many knots of gas and dust. Their sizes typically range from 17 billion to 56 billion kilometers, which is several times larger than the distance from the Sun to Pluto. Each contains as much mass as 3 Earths. M27 resides more than 1,200 light-years away from Earth in the constellation Vulpecula. With an apparent magnitude of 7.5, the nebula can be spotted with a small telescope most easily in September. M28 is a globular cluster located 17,900 light-years away from Earth in the constellation Sagittarius. It was discovered by Charles Messier in 1764. This 12-billion-year-old globular cluster is best viewed in August. M28 is considerably smaller than the neighboring M22. It is a Class 4 globular cluster, which means that it has intermediate rich concentrations of stars and that the stellar density at the core region is visible but slightly spread out. M28 has a combined mass of 551,000 solar masses and spans 60 light-years in diameter. It contains at least 50,000 stars. For comparison, there are only about 400 stars within 30 light-years of the Sun, an area the same size as M28. The cluster is most notable for being the first of its kind to contain a millisecond pulsar, PSR B1821-24. This dense neutron star rotates rapidly, about once every 3 milliseconds, and emits radiation from its poles that sweep past Earth as it spins. Much like the beam from a lighthouse, it appears to be pulsing to observers on Earth. Messier 29 is an open star cluster in the constellation Cygnus, the Swan. M29 is too faint to be spotted by the naked eye, but you can see it with a small telescope. The cluster lies an approximate distance of 4,000 light-years from Earth. M29 is located in the vicinity of the bright, supergiant star Gamma Cygni. It lies in a rich, crowded region of the Milky Way. It is classified as a Trumpler Class 3PN, which means it is a detached cluster without noticeable concentration. It contains both bright and faint stars. It has fewer than 50 stars, and there is a nebulosity associated with it. The 5 hottest members of M29 are giant stars belonging to the spectral class B0, about 160,000 times more luminous than the Sun. The estimated age of the cluster is 110 million years. Without the dust of the Milky Way obscuring the cluster, the stars in M29 would appear about 1,000 times brighter. The cluster's lights are blocked by the material that was around it when the stars were still forming. M29 is approaching us at 28 kilometers per second, or 62,634 miles per hour if we're using freedom units.
M30 is a globular cluster located in the southern constellation Capricornus. The cluster lies at a distance of 27,140 light-years from Earth. M30 was discovered by Charles Messier in 1764. M30 is best observed during September. Although globular clusters such as M30 are mainly populated by old stars, the density of the stellar swarm leads to some old stars apparently reclaiming their youth as blue stragglers. Using observations from Hubble, astronomers have identified two types of blue stragglers in M30, those that form in the head-on collisions between two stars and those that are in binary systems where one star siphons hydrogen from its companion. The cluster is approaching us at 181.9 kilometers per second. It has a combined mass of about 160,000 times the mass of the Sun. The estimated age of M30 is 12.93 billion years. The cluster lies at an approximate distance of 22,200 light-years from the galactic center, slightly closer than the Sun, which is about 26,000 light-years from the center of the Milky Way. M31, better known as the Andromeda Galaxy, is a large spiral galaxy located in the constellation Andromeda. Lying at a distance of 2.54 million light-years from Earth, the Andromeda Galaxy is the nearest major galaxy to our own. It is on a collision course with our home galaxy, the Milky Way. The Andromeda Galaxy is relatively easy to find in the sky as it is one of the brightest Messier objects. It lies in the vicinity of two prominent asterisms in the northern sky, the Great Square of Pegasus and Cassiopeia's W. The Andromeda Galaxy is one of the most distant deep sky objects visible to the naked eye. The best time of year to observe it is during the months of October, November, and December. M31 is the largest and most massive member of the local group of galaxies, which also includes the Milky Way, the Triangulum Galaxy, M33, and more than 40 smaller galaxies. The Andromeda Galaxy contains 1 trillion stars, more than twice as many as the Milky Way, which is home to about 200 to 400 billion stars. The two galaxies will collide in about 3.75 billion years. The collision will likely result in a new giant elliptical galaxy being formed. Messier 32 is a dwarf elliptical galaxy located in the Andromeda constellation. The galaxy lies at a distance of 2.49 million light-years from Earth. M32 is a satellite galaxy of M31, the famous Andromeda Galaxy. The dwarf galaxy spans only 6,500 light-years at its widest. Messier 32 is the member of the local group of galaxies which includes the Andromeda Galaxy, M31, the Triangulum Galaxy, M33, and the Milky Way Galaxy, among others. It was the first elliptical galaxy to be discovered. M32 is easy to find as it appears right next to the Andromeda Galaxy. It contains almost no gas or dust and shows no evidence of any current star-forming activity, but there is indications that star formations took place in the galaxy in the past. Like other elliptical galaxies, M32 is home to mostly old red and yellow stars. The galaxy contains a supermassive black hole at its center. The mass of the black hole is estimated to range from 1.5 to 5 million solar masses. Messier 33, also known as the Triangulum Galaxy, is a famous spiral galaxy located in the small northern constellation Triangulum. The Triangulum Galaxy is the third largest galaxy in the local group, after the Andromeda Galaxy and the Milky Way. The galaxy lies at a distance of around 3 million light-years from Earth. The galaxy contains around 40 billion stars, which is significantly less than the Milky Way, 400 billion stars, and the Andromeda Galaxy, 1 trillion. M33 is believed to be a satellite galaxy of the larger M31 based on their proximity, interaction, and velocities. The two galaxies are separated by less than 300 kiloparsecs. M33 is slightly more distant from us than Andromeda. A stream of hydrogen gas linking M31 and M33 was discovered in 2004, indicating a past interaction between the two neighbors between 2 and 8 billion years ago. The future of the Triangulum Galaxy cannot be predicted with any certainty, but it is tied to the Andromeda Galaxy. M33 will either be absorbed by Andromeda, be part of Andromeda's collision with the Milky Way, collide with the Milky Way itself before Andromeda does, or be ejected out of the local group of galaxies. Messier 34 is a bright, large, open star cluster located in the northern constellation Perseus and lies an approximate distance of 1,500 light-years from Earth. M34 is pretty easy to find in the sky. The cluster is located just north of the imaginary line drawn between Algol, the second brightest star in Perseus, and Almach, the third brightest star in the neighboring constellation Andromeda. The best time of year to observe the cluster in the northern latitudes is in the months of October, November, and December. M34 is one of the nearest Messier objects to Earth and is visible to the naked eye in good conditions. M34 is a relatively young star cluster with an estimated age between 200 and 250 million years. At least 19 stars in M34 are white dwarfs, stellar remnants with about the same mass as the Sun and a size comparable to that of Earth. Messier 34 is classified as a Trumpler type I3M, which means it is detached from the surrounding field and has a strong central concentration. It contains both bright and faint stars, and is medium rich, with 50 to 100 stars. M35 is a large open star cluster located in the northern constellation Gemini. The cluster consists of several hundred stars that lie 2,800 light-years away from Earth and is about 24 light-years in diameter. M35 is about 110 million years old. The hottest main sequence stars in the cluster have the spectral classification B3. M35 also contains more evolved stars, including several orange and yellow giants. M35 is the only Messier object in Gemini. The best time of year to observe in the northern latitudes is in the winter months, when the constellation is high overhead. M35 has a trompeter classification 3-3R, which means it is detached from the surrounding star fields with no noticeable concentration. It has both bright and faint stars, and is richly populated with more than 100 stars. M36, also known as the Pinwheel Cluster, is an open cluster located in the northern constellation Auriga. The cluster is 14 light-years across and lies a distance of 4,100 light-years from Earth. With an estimated age of 25 million years, M36 is relatively young and doesn't have any red giant stars. However, the brightest stars in M36 is about 360 times more luminous than the Sun. The Pinwheel Cluster contains at least 60 stars and bears a resemblance to the more famous Pleiades cluster M45 in the constellation Taurus. M36 is one of the fainter open clusters in Messier's catalog, but it can easily be seen in smaller telescopes. The best time of year to observe M36 is during the winter months, when Auriga constellation is prominent in the night sky. M37 is an open star cluster in the constellation Auriga. It is about 25 light-years in diameter and lies at a distance of 4,511 light-years from Earth. In binoculars, M37 appears as a hazy patch of light, but larger binoculars reveals a very compact star cluster, resolving the brightest stars. Small telescopes will reveal several hundred stars in the cluster. The best time of year to observe M37 is in the months of December, January, and February. M37 lies in the direction opposite the galactic center when seen from Earth. It is between 347 and 550 million years old. M37 contains more than 500 confirmed members. The cluster has a mass of 1,500 solar masses. It orbits through the Milky Way with a period of 219.3 million years, coming within 19,600 light-years of the galactic center at its nearest approach, and moving at a distance of 30,700 light-years from its farthest point in its orbit. Messier 38, also known as the Starfish Cluster, is an open star cluster located 4,200 light-years from Earth in the northern constellation Auriga. M38 is 25 light-years in diameter and is estimated to be 220 million years old. The brightest star in M38 is a yellow giant with the stellar classification G0 and a visual magnitude of 7.9. This translates to having an absolute magnitude of -1.5, which means the star is 900 times more luminous than the Sun. M38 is relatively easy to find because it is located within the polygon formed by the brightest stars of Auriga. The northern part of the polygon is marked by Capella, the third brightest star in the northern celestial hemisphere. M38 can be found roughly 2/3 of the distance from Capella to the bright Elnath, the second brightest star in the Taurus constellation, which lies south of Capella. Messier 38 appears quite large in binoculars. The cluster's X-shape is even easier to make out in 8-inch telescopes, which reveals stars along the cluster, many of them arranged in pairs. Best time to observe the cluster is during the winter months, when Auriga rises high for northern observers. Messier 39 is a large open star cluster located in the constellation Cygnus, the Swan. The cluster lies at a distance of 824.4 light-years from Earth. M39 is located about 9 degrees to the east and a bit north to the bright star Deneb. The cluster's apparent size is 32 arc minutes, making it larger than the full moon, which means that M39 is best observed in binoculars and small telescopes at the lowest magnifications. The best time of year to observe M39 is in the summer months, when Cygnus is high overhead. M39 is a relatively loose cluster of about 30 confirmed members occupying an area of 7 light-years in diameter. The cluster is approaching us at 28 kilometers per second. M39 has an estimated age of 200 to 300 million years. All its confirmed members are still in the main sequence, still burning hydrogen in its core, and yet to have evolved into red giants. M39 is one of the nearest Messier objects to Earth. Only the Pleiades M45, Winnek 4 M40, the Beehive cluster M44, and the Ptolemy cluster M7 are closer to us. Messier 40 is a double star cluster located in the constellation Ursa Major. M40 lies at a distance of 510 light-years from Earth. It is one of the few Messier objects that is not a deep sky object, but were cataloged by mistake. M40 is easy to find as it lies right next to Migres, one of the brightest stars in the Big Dipper asterism in Ursa Major. This is a star that connects the handle of the Big Dipper to the cup, or the star at the base of the Great Bear's tail. M40 can be seen in small and medium-sized telescopes and will show a pair of stars, one orange-yellow and the other white. It was discovered by Charles Messier in 1764. If Messier had a larger telescope, he would have discovered not one, but 2 other galaxies in the vicinity of the double star, the galaxies NGC 4284 and PGC 39934.